Hi everyone, today what I want to do is talk you through how to solve linear equations and the three different methods that you can use to solve those linear equations. So the first thing I just wanted to cover was, what do we mean when we say we're solving linear equations? Well, basically what it means is if we've got two linear equations, we want to find the point at which those two lines cross over each other. Okay, so when we say we're solving a linear equation, what we're actually doing is we're finding the point on the coordinate plane where those two lines cross over or intersect each other. So let's look at these two equations that we've got here. We've got one, which is y equals x plus 2, and we've got the second equation, which is y equals minus 3x take 6. So the first method of solving these linear equations that we're going to look at is solving them graphically. So what this means is that we're going to draw both of the lines on a set of axes like we've got here, and then we're just going to read off the graph the point at which these two lines intersect. Okay, so remembering when we're drawing our lines here, we need to identify two things on our linear equations. First, we need to identify the y-intercept, so where that equation cuts through the y-axis, and then we need to identify the slope so we can draw the second point on the graph. So if we look at this first equation here, our 2 is our y-intercept, and the number in front of the x is going to be the slope. In this case, there is no number in front of the x, so we can say that there is a 1 there. So our slope is going to be 1. Okay, so if we draw that, the first thing that we draw on the graph is our y-intercept of 2. So remembering that the vertical axis is our y-axis, the horizontal axis is our x-axis. If we just use the fact that each square is worth 1 point, okay, if we're drawing our y-intercept of 2, the first point on the line is going to be here. All right, now our slope is 1, which means that we're going up 1 and across 1 square for each point on the line. So we go up 1, going up 1, and then across 1. Our second point on our line is here. We can do that again, up 1 and across 1, and our third point will be here. So what we can do then is draw a nice straight line in between all of these 3 points. Okay, and that is going to be our first line. All right, so now what we need to do is we need to draw our second line. So once again, if we look at this line, our y-intercept is the number by itself, so -6. Remember, when we're looking at these numbers in the equations, we always take the sign that's in front of the number. So if there's a negative sign there, we need to make sure that we include that with the number. All right, our slope this time is again going to be the number that's in front of the x, or with the x. So in this case, our slope is -3. Okay, so let's first draw the y-intercept of this second line, which is -6. So if we go down 1, 2, 3, 4, 5, 6, -6, that's our y-intercept. So that's the point in which the line cuts through that y-axis. All right, so we look at our slope now. The first thing we notice about our slope this time is it's a negative slope. So that means we're going to go down 3, 1, 2, 3, and across 1. Okay, that's our second line there. All right, so what we need to do is we're going to probably need to extend both of our lines so that we can see where they intersect. Our top line here, we're going to have points going down in a trend like this. All right, and this second line that we've drawn, if we want to draw the next point up, we're going to be able to go up like this. Okay, so there's a distance of 3 up and 1 across in between each of those points. Okay, if we go again, this point here is going to be that point where both lines actually intersect each other. Okay, so we continue that line through there, and we continue this line through here. Okay, so the point at which those two lines cross or intersect is this point here. So the answer to this question is going to be the coordinate points of that point where the two lines cut through each other. So if we're writing this as a coordinate point, remember we always write the x coordinate first. So the x coordinate is -2. So remember, anything to the right of the origin here is going to be positive, anything to the left is going to be negative. So our x coordinate is -2, and we haven't actually moved up or down on the y-axis at all. So our y coordinate is 0, and that is the solution to our problem. So another thing that I just wanted to touch on while we were looking at solving equations graphically was rearranging equations. Okay, so to be able to graph our lines, we need to be able to rearrange these equations so that they're in the slope-intercept form. So remember what that means is that we have y by itself on one side of the equation. So if we have an equation in this form here that we've got here, this is what we call general form. Okay, so the first thing that we do when we look at this equation is we want to move the 2x to the other side of the equal sign. So what we do to do that is we take 2x from both sides of the equation, okay, because 2x is added or positive on this side of the equation. These two then cancel out, and what we're left with is 3y equals 26 minus 2x. Now what we want to do is remove this 3. Remember, when we're saying 3y, that's the same as saying 3 times y. So to remove the 3, we want to divide by 3. We have to divide both sides by 3. Okay, the 3's cancel out, and what we're left with is y equals 26 over 3. Take 2 over 3x. Okay, now our 26 over 3, can we cancel that down anymore? 3's into 26. No, we can't. Okay, so we can just leave it like that, and that's the equation of our line that we would use. We would then have our slope and our y-intercept, which we would be able to plot on our set of axes there. Okay, so now let's look at our second way of solving linear equations. Now this second method is called solving using substitution. So what this is, instead of graphing the lines, drawing them and finding where they intersect, we're still finding the point at which these two lines intersect, but this time we're using algebra. So the first thing that we need to know when we're solving using substitution is that one of the equations needs to have either the y or the x by itself on one side of the equation. So this first equation here has the y by itself on that side of the equation. So what we're doing when we're substituting is, all substitution means is we're substituting one equation into the other equation. So in this first equation here, it's saying y equals 3x take 2. So all we're going to do is put this 3x take 2 into the second equation instead of y, okay? Because the first equation tells us that y is equal to 3x take 2. So what we then get here is, when we do that substitution, is we get 5x minus 2 times 3x take 2. Okay, so we have to put that whole lot in brackets, because remember 2y is like saying 2 times the whole y. And in this case, we've been told that the y is equal to 3x take 2. Okay, and don't forget the equals 5 on the end. Now what we have to do is we can see from this equation now that we only have x's in this equation. So what we can do is solve the equation to find out what our x value, or the x coordinate of the point where those two lines meet, is. So to do this, we need to simplify, expand our brackets out. Okay, remember when we're expanding our brackets, it's like saying 2 times everything in the bracket. So we're still going to have our 5x to start with. We're not doing anything with that yet. Now the first number is going to be 2 times by 3x, or negative 2, don't forget that negative. So negative 2 times 3x is going to be 2 times 3 is 6, so it's going to be negative 6x. The next thing that we write down is going to be negative 2 times by negative 2. Now this is where we have to be careful here because we've got two negatives here. So when we multiply two negatives by each other, we actually get a positive. Okay, so negative 2 times negative 2 is going to be plus 4 equals 5. Okay, now we can collect our like terms, which means we can do the addition of these two x numbers here. So 5x take away 6x equals negative 1x, or negative x, plus 4 equals 5. So we want to now get the x by itself on that side of the equation. So we remove the 4. Because the 4 is added on this side, we're going to take 4 from each side of the equation, which means that we are left with negative x equals 5 take 4, which is 1. Okay, now the last thing that we need to do is we need to get rid of this negative sign in front of the x. Okay, so remember that negative sign is like saying negative 1. So to get rid of the negative 1, we're going to divide both sides of the equation by negative 1. Negative signs cancel out, so what we're left with is x equals negative 1. Alright, now remember this is the x coordinate of the point where those two lines intersect. So now what we need to do is find the y coordinate. We can do this by putting this value for x back into our first equation. So our first equation was y equals 3x take 2. So if we know that our x value equals negative 1, our y value when x equals negative 1 is equal to 3 times negative 1, because that's our x value, take 2. So our y equals 3 times negative 1 is negative 3, take 2, y equals negative 5. So remember to write this as a coordinate point. So the solution is, our coordinate point is going to be x is negative 1, y is negative 5, and that's the solution to our problem of where those two lines intersect. Alright, so let's look at the final method we can use. This is probably the simplest and the easiest method to use for solving linear equations, and it's called solving using elimination. So what we're doing when we are solving using elimination is we're essentially adding the two equations together. Okay, so the same thing again, what we have is two lines. We want to find the point at where these two lines intersect. So what we're going to do is add both sides of the equations together. Okay, so if we do that, what we're going to have is 3x, so everything on this side of the equation is going to be added together, and everything on this side of the equation is going to be added together. So what we're going to have then is 3x plus 4y plus 8x take 4y. That's everything on that first side of the equation is equal to 6 plus 5. Alright, so now we can cancel everything down. 3x plus 8x is going to be 11x. Right, 4y take 4y is going to be 0. So essentially what happens is these 4y's cancel out. Alright, they're equal to 0. So we're left with 11x equals 6 plus 5, which equals 11. Alright, we want to now get rid of the 11 to figure out what x is. So we're going to divide both sides of the equation by 11. These two cancel out, and what we're left with is x equals 1. Alright, so there's our x coordinate of where those two lines intersect. Now what we have to do is find that y coordinate again. So what we do is we put that x coordinate back into one of our original equations. So if we pick the first one, 3 times 1, that's our x value, plus 4y equals 6. So we've got 3 plus 4y equals 6. Right, we want to get the y by itself, so we're going to take away our 3 first. I'm going to take 3 from both sides. We're left with 4y equals 3. Now what we're going to do is divide both sides by 4 to remove that 4. What we're left with is y equals 3 over 4. So the answer to that question, or our coordinate point, is going to be x equals 1, y equals 3 over 4. Okay, and that is the solution. Remember, what we're talking about here is the point at which those two lines intersect. So that's the coordinate point on our coordinate plane where those two lines intersect. So that's outlining the 3 different methods that you can use to solve linear equations. Okay, so the 3 worksheets that I've given you will reflect that, and you'll be able to use these 3 different methods as the questions prompt you to do so.